Good day, everybody. This is an amazing problem in my opinion because there's only one visible constant. You're told that for some integer p, I use p there because that actually is minus the product of the roots, which turns out to be pretty inconsequential for this problem. But we're only given this constant, which is the coefficient of the linear term. We're also given that we have three distinct integer roots a, b, c, and we're supposed to evaluate the sum of the individual absolute values. Okay? That should give you some sort of hint that maybe the signs are going to shift around, but you're still going to get the same absolute value out of the thing. Now, this part right here is this is why Vieta, what they call the Vieta formulas, hold for the third degree case. You don't even need to know that if you know just how to expand, though. You don't have to know that this is Vieta's result, but when you expand this out, the negative sum of the roots manifest as the coefficient of x squared. Then the pairwise products manifest as the coefficient of x. And again, like I said earlier, p is minus the product of the roots because you have three minus signs. And so there's still a minus sign left. Okay. So this is something you could do without knowing anything about Vieta's formulas. You could just figure this out from reasoning. Now, oh yes, and something else that's important here. Notice that there's no x squared term, but you can think of that as 0x squared being present, right? 0x squared. So right here on this expansion, you see that minus the sum of the roots is the coefficient of x squared. That's why we could just set a plus b plus c equal to 0. The 0 you see here is the 0 you see right here. Okay. And still, though, we're in a position where we have two equations and three unknowns, which is underdetermined, but it turns out we have some stuff to work with here, and there's many ways to factor this. I just did it one particular way, but you'll see right here that c is the same thing as or minus c, minus c equals to a plus b, right? And again, you could have rearranged this other ways, but I just arbitrarily isolated c, and arbitrarily you could have factored this different ways also. Okay, so there's symmetry going on here. But you see minus c is equal to a plus b, but you see that's exactly what happened here. I replaced a plus b with minus c, right? That's why this becomes minus c squared. So you see, now we're getting a little bit of structure, and we have ways to do some bounding here. Now, you can rewrite this as ab plus 379 is equal to c squared. Now notice just a few things that'll help out here. 19 squared is 361, so it's less than 379, right? It's less than the 379 that you see right here. So we have to start with c. The absolute value of c is 20 or greater. That means c could be equal to negative 20. Or I'll just put plus minus, right? Plus minus, right? Plus minus 20. So, but I hope you see why we had to start at 20. 20 squared is 400, so it's bigger. It's well, this statement right here, we get to this point right here. We have to have c larger than c squared has to be 400. It can't be 361. That would make it too small for the constant 379 right here. Okay. Now, what we're going to do is we'll test 20, and we'll test 20. You can just tell by looking, folks, right here that if you have 20 in here, this would be, you would need 3 times 7 is 21, right? Or you could think of it as 1 times 21. But in either cases, you're not going to get a sum of 0, right? And that you could either do it with 20 or minus 20. But I hope that makes sense. In other words, if you put 3 times 7, 3 plus 7 is 21. It's not 20, right? And the same 1 times 21, you get 1 plus 21 is 22, right? So you don't get a plus b plus c is equal to 0 from this combination. Okay? Now, down here, let's see, we use 21 squared is 441. So you see, folks, with these factors would never get us a combination of this summing to 0, right? Again, just to be sure, just say if A were 20, right? Well, you could try -3 and -7 or -1 and -21. That's not going to sum to 0, right? And it's something similar for -20, right? Something similar for -20. All right, so in other words, -20 does not work. Y'all, now in a similar fashion, this doesn't work. You can check out the combinations here. What is this? 2 times 31 and then 1 times... It's very clear this doesn't work, right? You could try 1 times 61. But you can see that you're not going to get 21 summing. If you add 21 plus or minus 21 to 2 plus 31, you don't get 0, right? So you see, neither one of these cases works. Okay. Now let's go down to this case down here that would be for 22 squared. And again, y'all, I left out a little bit of the arithmetic, but 22 squared is 484. That's where this 405 constant comes from. And again, you guys can verify, but if you use the fact that 22 squared is 484, then you work with this, you'll see where the, work with this expression right here, you'll see where 105 comes from, okay? So now right here, we catch a little bit of a break. Notice that this would be equal to 5 times 21. Now, minus 22 is not offset. In other words, you could go minus 22 and then plus 5 plus 25, right? That's not equal to 0. Not equal to 0. Okay, but what if we try 7 times 15? Okay. Then you see you would have either case minus 22 plus 7 plus 15 is equal to 0. And again, y'all, I'm just testing that a plus b plus c equals to 0 condition. Or remember, that's what we're trying to do, is find combinations of factors here that sum up in a way such that a plus bc is equal to 0. All right? It's just trial and error. Now, also another possibility would be to let 22, remember it's the absolute value of c. All right? 22 minus 7 minus 15. Oh, this is equal to 0. I'm going crazy. Y'all, these are equal to 0. Let me erase this right here. Okay, so this would be equal 0. Okay, so you can see we have the same numbers, and that explains why the absolute value, we're using absolute value to represent the answer. It's not really necessary, but both of these combinations work, all right? And you can check I guess I should tell you no other combinations do work. The numbers just get too big, and the factorizations get too big, basically. And I didn't formally prove that for you, but that's what I think those are the only solutions. So right here, we would get, what are our values here? We can do absolute value of 7. We'll do -7 if you want. Plus absolute value of -15. And really, I could have just said find a plus b plus c, but we'd have to write down 2 different answers. Okay, and then plus 22, absolute value of 22. Okay, that equals 44, doesn't it? 35 or 40. 22 and 15 is 37. Yeah, that's 44. And you can see why the absolute value, you could also write this as absolute value 7 plus absolute value 15. And then you could make the 22 negative. But again, the absolute value bars ensure that we're just going to end up with 44 as our answer. Okay? And again, y'all, I didn't come close to rigorously showing you this. These are the only possibilities. I think there's a way to do that. I think though the 379 limits things, but I'm not real sure. That's kind of vague and a little bit too much hand waving. But anyway, here's your the solution. The answer would just be 44, right? Just equal to 44 right here. And again, as usual, if anybody discovers any other solutions, let me know. I think these are the only ones, but again, I'm not certain. These are sometimes a little tricky. You have different permutations or combinations that are easy to overlook. All right, so anyway, that is it.